In this lesson, you will learn how to multiply and divide rational expressions. Let's take a look at some examples that better explain this concept. In this particular problem, you're going to multiply these rational expressions together. There's a couple of different ways you can approach this problem. Because they are all monomials, if you'd like, you could just start with the numerator and combine them together into one and then move to the denominator. With the numbers, you can also cross multiply them if you would prefer. So with the numbers, the 3, 8, 4, and 15, if you're more comfortable, you can go ahead and multiply them across. So we'll multiply 3 and 8, which is 24. And then to combine the x's together, remember when we're multiplying variables, as long as it's the same variable, we're going to add the exponents together. In the denominator, we'll do the same thing. We'll multiply the 4 and the 15, which is 60, and then we'll add the exponents of the x's together, giving us x to the 5th. Now we have to look at the numbers separately from the variables. So 24 over 60, you need to try to reduce that to lowest terms. So you have to think what's the largest number that divides into both 24 and 60. And if you're not quite sure, you can start with a small number and work from there. So let's say like you just wanted to start with 2, which is fine. You would come up with 12 over 30. Then you might realize that 6 goes into both of those, which would give you 2/5. So once you've reduced it to lowest terms, bring it back up into the problem. Now we'll move to the variables, and x to the 4th over x to the 5th. You're subtracting those exponents. So 4 minus 5 is -1. So because it's -1, we have to move it to the bottom so that it's positive. Now another way to look at that is if you have 4 x's on top and you have 5 x's in the denominator and you cross out all of the matches, notice you have 1 left in the denominator, which is exactly what we're going to put in our answer. In this next problem, you have polynomials that are bigger than just monomials. We have a binomial and we have a trinomial. Now recall from previous lessons you've learned that you cannot simplify unless you have 2 monomials, 2 exact binomials, or 2 exact trinomials. So the first thing you want to think about is how can I create some matching binomials or trinomials? In this case, we have a monomial, which we cannot do anything with at the moment. X plus 4, the binomial, I'm going to go ahead and make a fraction by putting a 1 under it. And I'm going to keep that in parentheses to show that that's grouped together. The trinomial is going to be our key, because if we can factor that, we might be able to create 2 matching binomials that will cancel. So let's go ahead and try that. So remember, to factor this, you're going to focus on the 4 and find all of the factors of 4. So we have 1 times 4 and 2 times 2. And you're going to choose the pair that have a sum of that middle number 5. And the only option is the 1 and the 4. And you're going to put the 1 in one parenthesis and the 4 in the other. So now we're going to go ahead and transfer that up into the problem. So we have x plus 1 and x plus 4. Now in multiplication, what you want to realize is, especially once you have everything factored, that everything in the numerator is technically, you can connect it all together and make it just one big group. So it would be like 7x times x plus 4. Just put them together. In the denominator, you don't really need to worry about the 1, so we'll just drop down the binomials. So we'll have x plus 1 and x plus 4. So now it just looks like we're simplifying one big rational expression. So from a previous lesson, you've learned the only way you can simplify or cancel out binomials is if they have an exact match. And notice we have an x plus 4 in the numerator and the denominator. And anything divided by itself equals 1. So we can cancel those out. So then we're left with a monomial in the numerator and a binomial in the denominator. Now remember, if you have a monomial and a binomial, there's nothing you can do because a monomial can only be simplified with another monomial and a binomial with another matching binomial. So that would be as far as we could go. Let's take a look at another problem. Now this one, notice there's a division symbol. So you need to recall how to divide fractions. So just to give you a quick example over on the right side, if you had 3/4 divided by 1/2, remember you'll keep the first fraction the same, you'll change the division to a multiplication sign, and then you're going to take the reciprocal, which means flip the numerator and denominator of only the second fraction. And then from there you can multiply the numerator, the denominator, and then reduce. Or if you know how to cross cancel, you can cross cancel. Okay, so we're going to do the same process with the rational expressions we have here. First, what I would do is keep the first fraction the same, change the division to a multiplication symbol, and then flip or take the reciprocal of the second fraction only. So you need to do that each time you're dividing rational expressions. Now from here, we're going to look to see if anything can be factored. Now if we have monomials, which we do, 3x and 6x squared, at the moment we're just going to leave those alone. We've got two binomials. We have x minus 2, which there's no further factoring we can do with that. And then we have 2x minus 4. In the 2x minus 4, we can factor out the greatest common factor. So I'm going to do that over to the side as well. So 2x minus 4. The greatest common factor of these terms is a 2. You can factor out a 2 from both of them. So we'll bring that 2 out to the outside, and then we'll divide the original terms to see what's left. So the 2's will cancel, and you'll drop the x down. 4 divided by 2 is 2. So the 2x minus 4 factored into 2 times the quantity x minus 2. So what we're going to do is we're going to blend the numerator together. So we're going to put the 3x next to the x minus 2. And that's our numerator. Now in the denominator, the 2x minus 4, when we factored it, changed to 2 times x minus 2. Now we have two monomials. We have the 2, and we have the 6x squared. So you can just multiply the 2 and 6 together, and you'll have 12x squared for your monomial in the denominator. And then slide over the binomial x minus 2. So you might want to look at that again to see what I did. I combined the two monomials in the denominator, the 6x squared and the 2, and multiplied the numbers together to get the 12. And then the x minus 2, I just brought over. Now notice that we have matching binomials, so we can cancel those, and we're simply left with two monomials. So you'll need to reduce 3/12, which reduces to 1/4, and then subtract the exponents of the x's. So again, you get -1, and to make it a positive, you just move that x to the first to the bottom. So let me show you again. The x to the first and the x squared means you have an x in the numerator and 2 in the denominator. So if you cancel a match out, you're going to have 1 over x left, which means x is in the denominator. So that's why in the answer, the x is in the denominator. Let's take a look at one last example. Okay, in this problem here, we want to again look and see, are we multiplying or are we dividing? And it shows a division symbol. So what we want to do is keep our first fraction the same right now and flip over. So we're going to multiply by the reciprocal of the second. So in the second, we have an x minus 3 in the denominator, which is going to move to the numerator. And then we have our trinomial x squared plus 2x minus 3 now in the denominator. So we simply flipped that second fraction. Then we want to look for any opportunities to factor. And the only two I see are in the denominator on both fractions. So I'm going to copy down the numerator, x times x minus 1, for both, and then x minus 3 for the second. So both numerators stay the same, but the denominators will change. So over on the left, I'm going to show you how to factor the denominators. So 3x squared minus 9x is one of the denominators, and then x squared plus 2x minus 3 is the other. So we're going to factor out a 3 for the numbers, because that's what they have in common, and they each have an x. So our GCF is 3x, and then when we divide to see what's left, the 3's will cancel. You'll subtract the exponents of the x's, so you'll have 1x left. Then we have minus, and then 9 divided by 3 is 3, and then the x's cancel. Okay, so our first denominator is going to change to 3x times the quantity x minus 3. So let's transfer that over. 3x times the quantity x minus 3. Now let's go ahead and factor the trinomial. So we need factors of negative 3 that have a sum of 2. So we have 1 and negative 3, and we have negative 1 and 3. Those are our two options. And the only one that adds up to positive 2 is the negative 1 and the positive 3. So we'll put those in our parentheses. So then these two binomials will transfer over to the second fraction. So we'll have x minus 1 and x plus 3. Now remember, you can just connect the line between them and basically make one big expression or one big fraction. And then look for any matches for the binomials in the numerator and the denominator, and you can cross those out. So notice we have an x minus 3 that matches, so we'll cross those out. And we have an x minus 1 that matches. So in the numerator, that leaves us with only an x. And in the denominator, we have a 3x and an x plus 3. So our binomial is stuck. There's nothing else to cancel with it because it has to be an exact match. But our monomials, the x and the 3x, we can cross those x's out. And notice we have nothing left in the numerator. So if you have nothing left, you fill it in with a 1. And then in the denominator, we still have a 3 and an x plus 3. So that would be the answer for that problem. And that completes the lesson on multiplying and dividing rational expressions. Good luck with this lesson.